conduct the colorimeter experiment. So the colorimeter is an instrument used to measure the inorganic content present in the wastewater sample or industrial wastewater sample. Okay, and then so particular inorganic components gives a specific color. So when it dissolves in the water, okay, so that color have a particular wavelength. So that wavelength can be measured and then it can be quantified, and then we can find out how much particular component present in that wastewater. So this can be measured and then analysis of any wastewater can be done by using the digital colorimeter. So let us see how to conduct the experiment. Find out the concentration of unknown copper sulfate solution by using the digital colorimeter. So to find out the unknown concentration, so first we have to prepare the known ppm of concentration in solution. So first we have to prepare 100, 200, 300, 400, 500 and then till 1000 ppm. So and then by using that standard values, and then by using let us find how much the copper sulfate is present in any sample. So for that we have to prepare the required amount of copper sulfate and then dissolve in the 1000 ml of water, and then make it a particular ppm concentration. That is, we call it as the stock solution. From that stock solution you have to prepare the different ppm, that is 100, 200, like that you have to prepare 900 ppm. So that is the one part. And then afterwards you have to calibrate the digital colorimeter. So for that we are measuring the transmittance. So that is, here set 0 is there and then set 100 is there. So first you have to fix the set 0 by using rotating the knob and then make it to 0. So like that you have to make it to 100% transmissions. Okay, that is we have to do before conducting the experiment. So and then take the prepared 100 and then 200 concentrated solutions, and then take 5 ml of the required concentrated solution, add 5 ml of 3% TEA solutions, and then add 10 ml of water, and then make it ready. And then take a cuvette and then pour that solution, and then keep it in the digital colorimeter. Preparing the required amount of concentrated solutions. So take that sample in a cuvette, and then so before that we have to calibrate the digital colorimeters by setting 0 and then setting 100, and then after calibrations, so you have to fix the wavelength, that is by using rotating the knob, that is filters, that is 600. So this is the wavelength you have to use for the copper sulfate solutions. And then so you take the sample in the cuvette, and then you keep it in the sample holder, and then so this digital colorimeter directly gives the values of the percentage of transmissions. These value you have to note it down for the different concentration of sample. So once if it is standard values are measured, then you take the unknown sample, and then similar way you have to take it in the cuvette and then put it in the sample holder, and then put it and then find out the absorbance. So by the percentage of transmission of unknown value and then also percentage transmission of a known values. So then you have to plot the known value of the required concentration of ppm, and then by using that graph you can calculate the unknown values. So that will be easier. In detail is the percentage of transmission of unknown value and then also percentage transmission of a known values. So then you have to plot the known value of the required concentration of ppm, and then by using that graph you can calculate the unknown values. So that will be easier. In detail is in the colorimeter calculations, the aim is to find the unknown concentration of CuSO4 solution using a digital photoelectric colorimeter. So, and then you have to prepare the copper solutions as given in the manual, and then you have to prepare triethylamine solution, that is 3% as given in the manual, that is 3 ml of triethylamine in distilled water, and make it up to 100 ml in a standard flask using to get the 3% TA solutions. Once if you prepare these two reagents, then you have to prepare as per required ppm. Okay, so ppm so depends upon the concentrations, so you can calculate the respective ppm, that is the solution of a lower concentration are prepared by further diluting in the initial solutions. So if you want to prepare more solutions, so take that prepared solution and then dilute it, so you'll get the respective ppm. So in the calculation, so you have to prepare 100 ppm, 200 ppm, 300 ppm, 400 ppm, 500 ppm, 600, like that you have to prepare till 1000 ppm. So once if you prepared all the ppm respective concentrated solutions, so then you have to find out the transmittance or absorbance by using the photoelectric okay, colorimeter. And then once if we noted down that absorbance or transmittance, so that is serial number, and then concentration in ppm, suppose 100 ppm, so you have to note down absorbance or transmittance the values. So like that you have to find out all the given ppm. So by using that graph, so absorbance divided by, okay, that is observance divided by ppm, so you note down that values and then plot the graph, and then by using the unknown unknown value of you prepare the unknown. So unknown solution, the given solution you have to take it, and then you have to find out absorbance or transmittance. So and then respective values you have to plot. Okay, you have to plot it in the graph, and then graph, so you can find out how much the ppm present in the given solutions. So the results are okay, the final results are put it in the ppm or mg per liter, the concentration of the given sample.